Okay, I think it's time for us to get started. It's 10:40. I've got audio. I'm going to hit my little start button that's going to yell at me when I run out of time. So hello everyone. I'm Ben Armstrong, Program Manager on the Hyper-V team, and I'm here today to talk to you about Hyper-V Replica. Before I get started, first, how are people finding the show? Good? Enjoying it? I know we're just getting started. Hope you enjoyed the keynote. One thing I would like to ask, just to get kind of a understanding of the audience, is how many people here have just tried Hyper-V Replica in 2012? You know, played with it, kicked the tires. Only a couple of hands there, so that's good to know. I'll make sure that I don't skip over any of the basics as I'm going through. So this session is really focused on two things. The first thing that it's focused on is actually talking about a lot of the things that we have learned in the last year working with customers deploying Hyper-V Replica, some of the learnings, some of the interesting deployments, and some of the things that we now know to share with you guys as guidance. The other thing, of course, is to talk about some of the improvements that we've made to Hyper-V Replica in 2012 R2. I'm going to get really annoyed by these screens in the middle of my stage, but that's okay. I apologize for the people sitting here. I'm almost never going to be able to look at you, because I can walk over here and I can see these people, and I can walk over here and I can see these people, but you're always kind of in a dead zone. Hello. So it's all good. Just pretend that I'm looking at you from time to time. If I'm looking at the screen, really, I'm looking at you guys. Anyway, so we released Hyper-V Replica as part of Windows Server 2012. And we've actually had a really good uptake of it. We're really happy. We've been seeing a lot of positive feedback and a lot of excitement around this feature. So I've got a couple of customer quotes here. An interesting one to point out is the Work IT Safe Group. They actually deployed Hyper-V Replica because they were generally interested in disaster recovery, and then were affected by Hurricane Sandy in the US about 2 months after they deployed it, and were able to use Hyper-V Replica to get their servers, their workloads up and running quickly. So we've had a lot of good traction and a lot of good feedback with Hyper-V Replica, but it was definitely our first step into disaster recovery with virtualization. So with 2012 R2, we're continuing to invest in it. We've got some new features. And we also now have the Hyper-V Recovery Manager offering that sits on top of Hyper-V Replica. And I'll talk about that in a couple of slides in depth. So here's, as I've said, I want to talk about Recovery Manager. I want to do a deep dive on Replica and answer some of the common questions we're getting. I want to talk about planning for capacity and network. This is the biggest thing that trips people up. And I want to talk about some of the administration aspects of Hyper-V Replica. So with Hyper-V Replica that we shipped in 2012, we really designed it for a specific market. And the full background here is when we started looking at the disaster recovery space as a whole, we spent a lot of time going out and talking to people about, hey, what do you do for disaster recovery? What's your disaster recovery strategy? What do you like about it? What do you not like about it? And we went out and we talked to, high-end enterprises, and a lot of the time the answer was, our disaster recovery story is SAN replication. And it works, but it's really expensive. And what we don't like about it is all the cost and all the infrastructure and so on that comes with it. But the thing that was really interesting to us was that when we talked to small and medium businesses, the answer usually was, what disaster recovery solution? Because as far as they were concerned, and they were right, there wasn't a disaster recovery solution for them. First, for a small, medium business, any hardware-based solution is now out of their, budget range. There was no solution in their budget range. Second, for small businesses, how do you do disaster recovery when you only have one office? You don't have another site that you can fail over to. So in the first release, we really designed for that scenario. We designed Hyper-V Replica for the small, medium business scenario, where the two deployments we were looking at was a small business who was wanting to replicate virtual machines to a local service provider, or a medium business that had a small number of servers in 2 locations. Maybe a main office and a branch office, and wanted to do replication behind that. Now, of course, as soon as we released that product, we saw a lot of traction in those target markets, but we had enterprises coming to us and saying, hey, we really want to use this. And we had people come to us and say things like, hey, Hyper-V Replica, the underlying engine works good, but it's really hard to group virtual machines and do orchestration of failover of large sets of virtual machines, and so on and so on and so on. And our response for 2012 was, well, yes, we didn't design it for that. We know that those scenarios don't work well because that's not what they're designed for. So to address that scenario, hey, I'm an enterprise who wants to use this, we've built the Hyper-V Recovery Manager solution. Now, this is designed for larger scale deployments. It comes with some pretty specific scale requirements. Specifically, in order to make this work, you need to have a primary and a recovery site where you have System Center Virtual Machine Manager on both sides. So that should kind of set the bar for you as like, oh, okay, I need to, realistically, we're talking about you've got to have at least half a dozen Hyper-V servers on either side, so on. It is provided as an Azure service, and I have to say this clear because everyone gets confused about this. As soon as we say it's an Azure service, we get a lot of people going like, I don't want my data going through Azure. The data does not go through Azure. What this service does is it's responsible for configuring and orchestrating Replica and Replica-based operations, but the replication data is still going point to point between the 2 data centers. So you may ask, hey, why did you guys design this in Azure? And there are kind of 2 answers for this. The first one, which I would only say I wouldn't say this to a crowd in America, I would get in trouble for it, but I'll say it to a crowd here, is because you may have noticed that we're kind of into this Azure thing. It shouldn't surprise anyone to see Microsoft doing something on Azure. It's kind of a corporate direction. But the second one, a more practical one, is if you think about it, you've got a primary data center, you've got a secondary data center, you've got replication traffic going, you've got the ability to fail workloads over. When the disaster strikes, you don't know where you're going to be able to get to in order to orchestrate the failover. Now, the reality is that if you ran this piece on-premise, that might be the data center that gets hit. By running it in Azure, we can provide a guarantee that when the disaster strikes, no matter what happens, if you can get to the internet, then you can orchestrate the failover. You can make sure that your workloads come up and running. And it's actually, and I'll talk more about this in the next slide and a bit later on in the demo. It does get a bit morbid talking about disaster recovery, because one of the things that we constantly have to acknowledge is, and especially hard as the guy trying to encourage you guys to look at this, is while we're designing this, one of the things we have in mind is when the disaster happens, you might not be around. It may not be you who gets to orchestrate the failover. You may be stranded somewhere. You may be dead, unfortunately. That's a reality once we start looking at these disaster recovery scenarios. And I've heard stories from people where, yes, they had all these disaster recovery plans in place, but they were written down in textbooks that were in the office that was now 10 foot underwater. Or yes, they had the guy who was set up to orchestrate the disaster recovery plan, and here's the guy who was stuck in his house for 2 days because it was now cut off from the rest of the world because of what was happening around it. So we do a lot of thinking and design where we go, okay, we want to make sure that when the disaster strikes, you're in the best position possible. I'll touch on that a couple of times. So, a couple of key things that Hyper-V Recovery Manager does provide. The first thing, and this is really nice, is it goes through and does all the nitty-gritty host configuration for you. So I'm going to be spending some time later in this deck talking about different network configurations. And depending on your deployment infrastructure, you have to configure firewalls, routers, networks, gateways, certificates, so on. Hyper-V Recovery Manager does that all for you. It allows you to just go, that site, please make it work. It provides grouping of virtual machines and allows you to specify SLAs of virtual machines. It's still using the Hyper-V Replica engine under the covers, but it provides those higher level abstracts. And it also provides recovery plans. And this is, unfortunately, one of those morbid conversations again. Because one of the challenges that we have is, let's say you have an entire data center go down, and you need to fail it over to another data center. Now, I think we all know that if I went to one of your data centers or one of your server environments, and I yanked the power out, stuck it in a trunk, drove halfway across the country, hooked it back up in a new location, plugged up the power and just turned everything on, that it probably isn't going to work. So there are some tools we provide. Inbox, I'll be talking about those later. A couple of things that Hyper-V Recovery Manager provides on top of that is, the first one is it provides grouping and ordering. So you can go through and you can diagram out like, hey, if you have to fail over my entire data center, here's the services that need to come up first. Then bring up these services, then bring up these services. And it allows you to configure that all in order. The second thing it does, and this is once again one of those morbid but important things, is it allows you to put in manual step information. So that you can say, okay, if I'm doing a failover in my data center, first start the domain controllers, then start DHCP, then start DNS. Then you really need to talk to Bob. And you need to talk to Bob to get him to go and check this. And you can actually record that in the Hyper-V Recovery Manager tool. So that if someone who isn't familiar with the way your computers work ends up orchestrating the failover, they get the information of like, oh, and at this stage, you need to go log into this SQL server and make sure everything's okay before you proceed. Or at this stage, you need to talk to so-and-so. And it allows you a way to record the entire process for bringing your data center up in a way that's highly accessible. That information is stored in Azure so that no matter what happens, the failover can happen. So that's kind of what Hyper-V Recovery Manager does. I'm not going to be spending a lot more time talking about that today because I want to go in deep on Hyper-V Replica, which is what you're going to be using if you just use the inbox tools, and it's also the engine for Hyper-V Recovery Manager. So when we designed Hyper-V Replica for 2012, we had a couple of clear goals in mind. First, we wanted an inbox replication solution, and we wanted everything to be inbox. And that's a key thing to understand. You get Windows Server Standard Edition, Data Center, even the free Hyper-V server. You have everything available to do disaster recovery with Hyper-V inbox. The second one here, an interesting point to make, is we are really focused on disaster recovery scenarios. I get a lot of people who look at Hyper-V Replica and they get really excited about, hey, I could use this to replace clustering, or hey, I could use this to replace backup, or so on. That's not what Replica is about. Replica is about disaster recovery, and that's where we're going to continue to remain focused. We are application agnostic, and we're operating system agnostic. This is a big deal for us. Was we wanted to make sure that we didn't have a list of what does and doesn't work with Hyper-V Replica. So we've done a lot of work to make sure that we replicate the virtual machine And we don't care what's inside the virtual machine. We guarantee that your data is replicated over to the other side. And the final one, which is a big point, is we're storage agnostic. So when we started working on this, one of the biggest pieces of feedback that we got was that people weren't happy with how much they were having to pay for SAN replication. So we wanted to make sure that we took no dependencies on storage whatsoever. But we also do not require any sort of similarity between the storage on the primary site and the recovery site. And this is really important because when I talk to people who are doing Replica for medium business, the deployment I see most often is they have a SAN in their head office. They have one SAN, that's the only SAN they own. They have a SAN, they have a small Hyper-V cluster, they have a bunch of workloads there. They then have branch offices that are just running direct attached storage, just SATA disks. And they can use Hyper-V Replica. It doesn't matter that one side is using SAN and the other side is using DAS. So that was our goal in 2012. In 2012 R2, we made some more improvements. We allowed you to configure different replication intervals, and I'll talk about that later on. We added a new functionality called extended replication. We've added some extra support for Linux as a virtual machine. And we've done a lot of work around making sure that you can upgrade to R2 and still have a disaster recovery story throughout the whole process. So now I'd like to spend some time just going through some of the basic deployment scenarios that we see going on. The first and most simple one is, you've got two sites and you want to replicate some virtual machines between them. Now that's very simple. This is the medium business deployment. Nice, simple, straightforward. The next one, this is actually the one that we've focused on a lot, is if you're a small business and you only have a single site, we've done a lot of work to enable local service providers to be able to offer Replica as a service to you so they can act as your Replica target. Now, a big chunk of the work here has been we've designed Replica so that it works without Active Directory being available in both places. It works in a secure fashion when going over the internet. So you don't have to do any strange VPN stuff or so on. It's all been designed so that someone can offer this as a service. In the R2 release, we're actually adding a third deployment scenario, which is the one that we call the extended replication scenario. And here we allow you to do replica from a primary to a secondary to a tertiary replication site. So I'm going to switch across to my demo. I'm going to show you how this works and talk through some of the details of Hyper-V Replica. Now, in fair disclosure, I am doing this all from a single laptop, and I'm doing some smoke and mirrors to make fake second and third servers. So Replica 1 and Replica 2 aren't real servers. I can use them to replicate my virtual machines to, but I can't actually start a virtual machine on them. If I try and do that, it's going to fail. So I will do a lot of the setup here, but I won't actually demonstrate failover, which I would like to do, simply because I'm doing this all on my laptop. So here I have a running virtual machine, Replica demo, and I'm going to go ahead and enable replication. So this is just using the inbox tools, what you get in any version of Windows Server. Go ahead, I want to enable Replica, and I want to send it to Replica 1. So here we have the option of configuring our authentication type. Now today I'm going to be using Kerberos simply because that's a lot easier for me to set up. And for most of you, if you're looking at this in a test lab, if you're playing with it, you're probably going to use Kerberos as well. The key thing to understand here is we also support the use of certificate-based with the data being transmitted over HTTPS. And that is specifically for the model where you have a service provider or one business providing a replication target for another business, and you don't have a unified domain namespace, so Kerberos won't work. So I'm going to use Kerberos here. The next thing I'm going to highlight is the way I have this virtual machine configured. This is actually something that we're now documenting as a best practice, is that you should really be configuring your virtual machines that you're planning to use Replica on with a separate hard drive that you use for the guest page file. Now the reason for this, and I'll go in depth on this later in the deck, is one of, like, when you're doing Replica, chances are your biggest thing to consider when you're planning and scoping and sizing is how many virtual machines can I replicate over the network connection that I have. And there is one factor that impacts that, and that is how much storage I/O are we trying to replicate. Well, what you can do is you can take a virtual machine, you put the page file on a separate disk, and you can say, don't send that page file. Now, this means that as Windows is running, it tends to mess around with the page file a lot. Once you've done this, that data is not being sent over your network link now. We're just sending the operating system data. Now, something that a lot of people don't realize is that these days, modern Windows, very resilient about having its page file messed with behind its back. So if you do this configuration and you do a failover and the page file disk isn't there, Windows won't bat an eyelid. It just goes, oh, I've got a page file that's stored on a disk that's not there. I'm just going to create a new page file on my system drive and get up and running. So this is a great way to reduce the I/O that you're sending over the network. So we're going to do that. Now here's the first change for 2012 R2. Everything up until this point has been exactly the same as 2012. With 2012, we would only send virtual machine replication every 5 minutes. Now, we had a lot of people come back and ask for us to change this. And we've made some changes here. But before I talk through that, let me step through some significance of what we call the replication frequency and how that kind of ripples throughout the system. So we like to talk about replication frequency, which is how often do we try and send you data across the wire. In 2012, it's 5 minutes. But once you start looking through the system, there are a couple of other things to consider about this. Whatever our replication frequency is, you can take that and double it, and that is on your worst day how far behind things could be. So if you imagine we have a 5-minute replication frequency, on your worst day, the main system goes down just as we're about to send the next replication cycle, which means that your backup copy is now 10 minutes behind. So that's the first thing to consider. The second thing to understand is some of the failure logic that we have. And I'll talk about this also in depth later on. But in a nutshell, we designed Replica to try and walk the knife edge between being resilient enough but not being too resilient. So you may wonder, what do I mean by that? What do you mean by resilient enough and too resilient? So when we were designing Replica, we spent a lot of time talking to people with different disaster recovery solutions in place. And we heard a lot of complaining, a lot of whining, and a lot of horror stories. And so there were a couple of things that we came away from that. The first one is, people don't want a fragile replication solution. You want a replication solution that, as much as possible, tries to make things work. So we heard from people who had replication solutions where, if one replication cycle was missed, they were firing alarms and alerts and so on. And they got sick and tired of this, because they were in a mode where every half hour something was complaining about, like, ooh, this took 30 seconds longer than I expected it to. On the flip side, we heard lots of horror stories where people had replication solutions which tried to be too resilient. And what would happen is the recovery site would fall behind the primary site, and the replication solution would just keep on trying, and keep on trying, and keep on trying, and keep on falling further and further behind, and never raising the red flag and saying like, hey guys, something's wrong here. So that when the disaster finally hit, they find out that, hey, their backup site is days behind their primary. So we built a logic in Hyper-V Replica where we basically said, okay, if we have a replication cycle fail, we're not going to throw up a red flag straight away, but we will retry, and we will retry up to 12 times. And if we fail 12 times, then we're going to throw up the red flag, we're going to put the replication relationship into a critical state, and require some manual intervention. So 2012, 5-minute interval, means that on your worst day, your virtual machine could be 10 minutes behind, means that we will retry up to 60 minutes, so up to an hour, before we go, this is a problem. So we shipped Hyper-V Replica in 2012, and we had a bunch of people come back and say, hey, we want to be able to change this. And the people tended to fall into one of two camps. The first camp said, we want to make this much smaller. Because they said, okay, we understand that you designed Hyper-V Replica for small and medium businesses, you designed this for metropolitan area networks, for commercial broadband, so on. However, I want to use this in my data center. I want to use this between servers that have gigabit network connectivity, have 10G, whatever, and I want you to just send the data as quick as you possibly can. So for these people, we've provided the option of 30 seconds, which means worst day, your backup's 1 minute behind. It also means we'll go into a failed state if we haven't been able to replicate for 12 minutes. Something to highlight, getting a replication solution that's only 1 minute behind in worst case will cost you a lot to do in hardware. So it's pretty cool to have this available in software. The other side of the fence, though, is where we provide 15 minutes as your replication frequency. And this was interesting. I actually met with one of these customers about 2 months ago. And the customers who are asking for this were the customers who are saying, hey, this Hyper-V Replica stuff is great. Really excited that it's being designed for small, medium business to go over like a commercial broadband link. But I want to do it over a satellite link. And the customer I actually met with, this was about, as I said, about 2 months ago, I met with the education department of Saudi Arabia. And they literally have schools in the middle of the desert, in the middle of nowhere, where they've got a satellite link out there. And they're trying to figure out, like, how do we make sure that we have a DR solution for these environments. So for those environments, a 15-minute replication frequency means that we now tolerate up to 3 hours of network disconnection before we give up and throw up our hands and say, something's gone wrong here. So I'm going to go 5 minutes for this. So then we have the option for recovery points. So this is all about extra layers of security and extra layers of safety in your solution. So Hyper-V Replica is an asynchronous storage-based replication solution. And what this means is that as your virtual machine is running, we are logging the writes it performs to disk, and we're sending that data over to the replica side where we replay it into the replica virtual machine. Now, this is normally done in a mode that is both operating system and application agnostic. Now, we control our storage, so we make sure that there's no issue with pending I/O or so on. We have complete control over that. And our expectation is that, and certainly our testing has borne this out, that you should be able to use Replica, and even in the worst case where you're doing an unplanned failover, all it's going to look like is a PC that's been powered off instead of being cleanly shut down. That said, we get a lot of people who they go, Microsoft, I know you say that this is going to work, but I'm not entirely trusting you right now. I need to have an extra level of assurance. So we provide a couple of options here. The default option is, we're just replicating your virtual machine, and the replica copy is just the latest copy of your virtual machine. The next option is to create hourly recovery points. And what this basically looks like is we're still doing replication at the 30-second, 5-minute, 15-minute frequency, whichever one you selected. And we're still sending that data over. But what we're doing is on the remote side, once an hour, we take a checkpoint. We take a moment where we go like, okay, let's just remember this point in time. And what this allows is it means that when you do a failover, let's say you grab the latest data and something's wrong, something's missing, something got corrupted. As I said, not something that we've seen, but something that people are concerned about. Recovery points would give you the option to say, you know what, let's go back an hour earlier. And we actually allow you to try out multiple recovery points and find the one that works best for you. And then you can go with that. The final option we provide here is to use VSS. And what this does is this is kind of the final definitive word, because here we're using the Windows VSS infrastructure to ensure that an entirely application consistent and data consistent point in time is sent across as part of the replication. A VSS-based recovery point is as good as having a backup of the system. So you may wonder, if that's so good, why don't you turn it on by default? And why, when I turn it on, are you only doing it every 4 hours? What's the story here? Well, taking a VSS snapshot of a system is actually a fairly expensive operation. It uses a bunch of CPU, it uses a bunch of memory, it causes a bunch of I/O churn. You do not want us to be constantly taking VSS snapshots of your system. It would cause performance issues. So that's something to be aware of. If it's a system that you care about and you have the breathing room for resource, then you probably want to turn this on to provide the ultimate level of security there. But if you're getting close to the wall on resource, that's something to consider. So final page is the initial replication method. I actually really like this page because this is one which I like to point out, like this is actually an example of Microsoft thinking through real-world scenarios. So you'll see the default option here is send the initial copy of this virtual machine over the network. Because something to understand is when it comes to Hyper-V Replica, actually sending the ongoing I/O across the network isn't that big of a deal. Most servers, their moment-to-moment I/O it's reasonably sized. The challenging thing is actually getting the burst-based base copy of the virtual machine across to the other side. That's a lot of data. So the first option we provide is just send an initial copy over the network and send it straight away. Great if you're in a test lab, but in most real-world scenarios, not what you're going to want to do. What you can do then, there are a number of options here. So let's imagine you're in a production environment, and you think you have enough network bandwidth between your primary and your secondary site to send it over the network, but you don't want to do that in the middle of the day because you're going to affect the performance of business. There you can say, okay, I'm going to send my initial copy over the network, but I am going to schedule this, and I'm going to do it on Saturday. And the great thing is you can go through and get this all set up, and now you can go home, and on Saturday, Hyper-V is going to kick in and automatically send that initial copy for you. So that's one option. The next option is send an initial copy using external media. The other way to word this is put this on a USB disk I'm about to get in my car. Because for a lot of people, this is actually the most practical approach. And we do support it. Get out your 500 gig USB disk, choose external media, put it, we'll copy it onto the USB disk. We set up replication and put it in a pending state. You drive over to the remote side or drop it in the post or do whatever it takes. And when the virtual machine's over there, you go and complete the replication. So the final option that we have is both an interesting and a dangerous one. And this actually came up because we had a number of customers who came to us and said, you know, we're really interested in Hyper-V Replica. We already do offsite backups. And what we'd really like to do is we'd just like to restore one of those offsite backups in our backup location and use that as the basis for Replica. And that's what this option does. This option will reach out to the Replica server, and it will find a virtual machine which has the same name and ID as the virtual machine that you're trying to replicate. And we will go through and we will compare the disks, and we will figure out what the differences are, and we will make them look the same. The reason why I say it's dangerous is we will make the virtual machines look the same, even if you point us at a completely different virtual machine. So if you take your file server and manage to make us think that that SQL server is a backup of it, we will make it a backup of the file server. We will destroy all the data that is there and send you data. Not a good idea, so do be a little careful with that. So I'm going to say send this over the network immediately, and go ahead. So now I'm going to go to Replica 1, and I have my virtual machine here. So some things that I'd like to point out now that I have my Replica virtual machine up and running. If I bring up the settings, this one I actually really like, because this is an example of thinking through the end-to-end scenario. So I can come here, and I can actually say this is a Replica virtual machine. When I fail over, here's the IP address to give it. And the reason why this is here is, first, obviously, you're going to a different data center or a different location. And unless you're using DHCP, you're going to have a different IP address. The second reason is when the disaster strikes. You know, when there's floods, when there's earthquakes, when there's whatever, when there's panic and pandemonium in the streets, that is not the time that you want to be doing IP address configuration. It's not. You know, it's not the time you want anyone to be doing IP address configuration. They're going to type something wrong. They're not going to be focused. You know, yeah. We allow you, when it's a sunny day, when life is good, you can sit down, put in all the IP address information. It's now locked into the system. When the virtual machine fails over, we put it in automatically. And one of the things that we've done in the R2 release is that we now support this IP address injection for Linux virtual machines as well as Windows virtual machines. So you can go ahead, configure this, and away you go. So now I've done this, I can actually extend this replication. And what this is going to allow me to do is, you'll see that this wizard is mostly the same, but now I'm going to say, you know what? Make another copy of this virtual machine over on Replica 2. And we did this for an interesting reason. In short, we did this because we were wrong and we missed a detail when we were working on the first release, which I find it fascinating. You get out into the real world and people do different things. So we built this replica so that service providers could provide it as a service to local companies. And we went out to service providers and we really pitched it to them. I'm like, hey, we've got this Hyper-V Replica feature. You can provide it as an offering to local businesses. We think it'd be great. And most of the we had a couple of service providers implement it, but most of the service providers came back with the same message. They said, this looks really great, really cool technology. We're going to use it ourselves first to get rid of our SAN replication and save us some money. And yeah, maybe offer to customers. But first we want to use it ourselves. And that was kind of bittersweet news. They're using the technology, they're happy with it, but not in the way that we were expecting. And so extended replication now allows people to say, like, okay, sure, the service provider can use replication internally. They can also offer it to a customer. So I'm paused on this page just to highlight, with extended replication, you can use different authentication methods between the two jumps. So I could use Kerberos on the first jump and certificate based on the second. I'm just going to jump through and do the defaults here. So that's going to extend my replication, and now I have a third copy over here. So that's kind of the step through of Replica. And one thing I'll highlight, I haven't shown you this, but everything that I just did with the UI, you can do with PowerShell. So now I'd like to talk about some of the failover scenarios. One of the big things we invested in Replica is we want it to be possible and easy at any point in time for you to validate that Replica is happening and Replica is healthy. And one of the features that we built in is test failover. And what test failover is you can go to your recovery virtual machine and you can say, I want to do a test failover of this. And we will actually make a clone of that virtual machine. We will fire it up. We will automatically disconnect it from the network so it's not going to cause any network conflict. But we'll allow you to go through and validate. They're like, yeah, it boots, it works, everything looks good. And you can do that as much as you want. Now, if you are the unluckiest person in the world, you will have just thought, but what if I'm doing a test replication and the disaster happens then? Don't worry. We do, like throughout a whole test failover, we do maintain the replication process. So even if that did happen, you're still protected, and you can roll back a test failover and do a full failover. The next one we have is planned failover. And planned failover happened because what we found talking to people is there are many times when you're about to have a disaster and you actually know that it's coming. When you look at things like storms, floods, maybe massive power outages, there are times when you do get just a couple of hours notice. And what a planned failover does is it allows you to shut down the virtual machine on the primary site and ensure that all remaining data gets sent across so that you can guarantee no data loss. The final option is unplanned failover. An unplanned failover is when the disaster's hit, it's too late, and you just need to start up the system. So that's also completely supported. Of course, in an unplanned failover, you will have some amount of data loss. Couple of minutes depending on how you've configured the replication frequency. So, just a second. Those are the scenarios. What are some of the considerations? Well, there have been some interesting discussions around what actually happens with networking. So I showed you the IP address configuration feature, which is great for if you're using static IPs. If you're using DHCP, obviously that's just going to work. However, and people have been caught by this, make sure you have a DHCP server on the other side. If it's something that you're failing across, make sure it comes up first. Network virtualization, technology that we shipped in 2012, is also a great tool for ensuring that virtual machines move across, keep their IP addresses, and keep their network connectivity. The final point to make here is DNS. We do not do anything in any of these approaches to mess around with DNS. Now, if you're familiar with DNS, you'll know that the average DNS client has a 15-minute cache. So if you take a server that's in one data center with one IP address, and you shut it down and you move it to another data center and give it a new IP address, it's actually going to be about 15 to 20 minutes before various clients start resolving that network name. For most people that I've talked to, they're looking at disaster recovery and they go, hey, 15 to 20 minutes of network outage is not a bad deal if I kept all my data and the workload's back up and running. For people who are concerned about this, 9 times out of 10, we've just ended up telling them, hey, DNS client cache is configurable. Go and tweak it and make it 5 minutes or whatever you need for your environment. But that's something to keep in mind. Another question that comes up around failover is, what about split brain? And when I say split brain, this is kind of an industry term. Like, what about what do you guys do to make sure I don't have a VM running on either side? You know, what's there to stop me from just going to the recovery side and firing up the VM? Or, in the more reasonable thing, so I have a disaster, my primary site goes down, I do the failover to my recovery site while my primary site's down, and my primary site comes back up without my knowing, and Hyper-V tries to automatically start those virtual machines. What happens here? Well, we actually handle this in a fairly simple but effective manner. And the manner that we handle this is, once you have enabled replication on a virtual machine, whether it is a primary or a recovery virtual machine, if you come in and try and start it, or if we try and automatically start it, as part of the startup, the process, we follow a very simple piece of logic. First step, can we find the other server on the network? You know, the other Hyper-V server. It doesn't matter whether we're the primary side or the recovery side, we go through this logic. Can we find the other Hyper-V on the server on the network? If no, we're going to assume that it's gone and we're going to start the VM. If yes, can we find this VM on that server? If no, we're going to assume that it's gone and we're going to start the VM. If yes, is that VM currently running? If it is, we're not going to start because it's running over there. So you can test this really easily. If you set up Replica and just go to the recovery machine and try and start it without doing a failover, we'll give you a nice little error saying, no, it's running over there. But if you shut down the primary, start up the recovery, and then try and bring up the primary and try and start the VMs there, we'll give you the same error message and say, no, we can see that this virtual machine is running over on the recovery. So, let's say you've done a failover, and how do you get back to a good state? So your primary site's gone down, you've done a failover, what happens here? Well, there are two options. The first one is fail back. And this is where the primary site comes back up, and what we actually do, and we have a number of ways that we allow you to do this, where we allow you to reverse the replication relationship. We allow you to turn your recovery site into your primary site and vice versa, so that you can reverse the replication relationship and get back to good. The other option, new in 2012 R2, is you can take advantage of extended replication. Now, if you have extended replication, you have extra copies of the virtual machine. You have more flexibility about how you recover post a failover. So the next area I'd like to dig into is capacity planning. This has actually been one of the biggest areas of confusion and question from customers. You know, the number one question we've had is, how much network bandwidth is needed? Next one, how much storage? You know, do I have sufficient storage bandwidth? What's the CPU impact? Now, for a lot of these questions, the reality is that you're practically asking how long is a piece of string, because it's really going to depend on your deployment and on your configuration. And what we've actually done is we've recently built a tool which we call the Hyper-V Replica Capacity Planner. And what this is a tool you can go and download, and you point it at a Hyper-V server or a Hyper-V cluster, and you can go through and you can select, okay, here are the virtual machines on the system that I want to replicate. I don't have the next screenshot. What we do then, we allow you to select the virtual machines that you're thinking about replicating, and we allow you to basically tell us how long do you want us to spend gathering data. And of course, the longer you give us, the more accurate it's going to be. But we will generate a report from this tool where we'll actually give you an idea of, hey, if you ran Replica on this virtual machine for the period of time that we monitored it, here's the sort of storage impact it had. Here's the sort of network impact it had. And here's the considerations to take into place. So that's a really handy tool. Next, let's talk about some of the specifics here. The first thing to talk about is, because people ask about CPU and memory, there's practically no overhead for CPU and memory. For storage, it's pretty much, it's not a big deal. For IOPS, there is an impact. And that's kind of a problem because a lot of people don't understand where they are in regards to their IOPS. I can tell people like, oh yeah, it'll double your IOPS. And the problem is most people don't know if you're currently at 10% of your IOPS utilization or 80%. So if you're at 10%, doubling your IOPS, yeah, not a big deal. If you're at 80%, doubling your IOPS is a big deal. So let's dig into the storage and some of the changes in R2. So here I've actually called out 2012 with recovery points versus 2012 R2. So something to understand is I showed you the recovery points feature of Hyper-V Replica. That feature has a definite impact on the storage on the Replica server. So what's happening here is your virtual machine's running, we're logging the I/O, we're sending that over the network. Now if you don't have recovery points enabled, we're sending that over the network, we're playing that data into the virtual hard drive on the destination side, and then we're throwing the log away. Now when you're in that mode, you basically see the same I/O load on your replica server as your primary server. That's an important thing to understand because I've seen a lot of people who think that they can throw replica VMs on a server and have them have no impact whatsoever because they look in Hyper-V Manager and they see the VM's off. Maybe off, but the disks are on. The I/O is happening. So that's something to know from an I/O point of view, they're running VMs because we are replaying the storage. But the I/O in the space is pretty much the same if you haven't enabled recovery points. The picture changes drastically if you do enable recovery points, though. So in 2012, what we would do is in order to do recovery points, we would take the logs as they came in, and we would replay them into differencing disks. We would basically create virtual machine snapshots under the cover. Now, there are two problems that we found with that. The first one, which just isn't going to go away, this one you just have to accept, is that if you enable recovery points, then you need to have some extra space on the replica server so that we can keep track of that data. If you have a replica server where you're like, we're going to be running tight on storage, then recovery points could be an issue. The second issue that we found with replaying the log files into the differencing disks was that it actually created a lot more I/O churn on the replica server. You can see here up to 5x the number of IOPS depending on how we had things configured. So in 2012 R2, for recovery points, rather than replaying those logs into differencing disks while things are running, we actually just keep the logs around. And we only replay them into a differencing disk if you ask us to use a recovery point. So that's a big change. So the performance impact of recovery points has gone down significantly. However, there is still a performance impact, and more crucially, there is a space impact. So now let's talk about planning networking. So there are basically two network topologies that we see people doing out there. The first one is, you're going over the network, you use certificate-based authentication, and you use HTTPS. So you have a primary VM, you have your firewall, you're going over here, you're using HTTPS. The second one is that you use a VPN tunnel and that you use AD between both locations. Now these obviously have fairly typical pros and cons. The VPN infrastructure is trickier to put in place. The firewall infrastructure has more security concerns to consider. So hopefully this is fairly straightforward. The more interesting discussion becomes around what can we do to, let's say I've set up Replica and so on, and I'm trying to do this over a really slow link. What are my options here? So one of the first things that people always come to us with is like, hey, Hyper-V guys, it would be really great if you could compress the network data that's being sent for Replica. Well, I'm sorry, we're already doing that. That was built into 2012. We compress that data by default before we send it. What has been really interesting is we've done a lot of work with some third-party WAN optimizers and WAN accelerators. And what these guys bring to the table, crucially, is network-based deduplication. So we've actually published some white papers on this. We did some proof of concepts with Riverbed with their Steelhead WAN accelerators, and the savings were pretty staggering. So for ongoing replication, we saw savings in about the 80 to 90% rate. So the amount of data being sent across the wire was 10 to 20% of what we would normally send. But where things got really insane was around the initial replication. So sending that first big copy of the virtual machine across, that's where we saw, as you can see, 95% performance saving. And you can see in the study that we did, if we did this without the WAN accelerator, where we were sending 1.8 terabyte of data across the network, with the WAN accelerator, we sent 86.5 gig. So that's definitely something to be considering if you're looking at deploying this on a low network environment. Next common question that comes up is network throttling, especially for people who are doing this over a broadband connection. They're doing it over a shared connection. They've got other traffic running. They don't want Replica swamping it. Thankfully, this is easy to do with just the inbox QoS support in Windows Server. So there's basically the PowerShell commandlet that you can go in and you can restrict the network traffic. So now I want to jump through. We are almost out of time, so I am going to have to speed up to go through this section and talk through some of the administration aspects. So monitoring replication health is a big question. Now we've provided some great tools in box for this. This is the replication health report that you see if you just right-click on a virtual machine that's replicating. And you can see a whole bunch of data here. Some key things to call out, the average latency. How long behind the primary is the recovery virtual machine on average? How many errors have we encountered? And how many successful replication cycles have we had? And you can actually see here's one where we've had some errors. We provide you that information. So here we're saying we've had a failure. Now it's really interesting. I've seen the one to keep an eye on here is we have a warning state. And warning state basically says the virtual machine is currently okay, but we've had missed replication cycles. We've had something go on. Two key things to call out here. The first one is that all this information is stored in the event log, so it's easy to get to. The next thing to call out is that we have actually done the work with the Hyper-V MOM pack, so that if you're using SCOM in your environment, all of this information also comes up through System Center Operations Manager. So, I'm going to bring this on. What do we do if there is a network outage? I've already talked a bit about this. We do have automatic retry. We do it up to the 12 cycles. But what do we do if we go beyond the 12 cycles? So by default, we will put the replication into a failed state and require manual intervention. There is actually a setting on a virtual machine where you can go in and you can say, hey, Hyper-V, if replication fails, try to resynchronize automatically. And that's my timer. That is really loud. I'm trying to wrap up. You can say, try and resync automatically. And that setting has three options. You can either say manual, which is the default. You can say automatic as soon as you notice. Or what we see most people doing is you can say, if replication fails, try and resynchronize at 2 in the morning. You can actually set a schedule and say, this would be a good time to try and resynchronize. So I am out of time. I'm going to jump through the next slide. This is some common questions we get. Storage migration, everything just works with Replica. Live migration, people ask us about this. You can always live migrate the primary Replica virtual machine, but the secondary, recovery machine, live migration only works if it's in a cluster. If it's outside of a cluster and you do live migration, then that's not going to work. I'm going to jump over this slide because there is one critical thing that I want to talk about, and this is upgrade. So the question here is, let's say I'm doing Replica between 2012 and 2012. How do I upgrade that environment to 2012 R2 and maintain protection throughout? And the way you do this is, first, you upgrade the Replica side. And this is key. Do not just do this in any order. If you upgrade the primary side first, you can hit problems. So first, you upgrade the Replica side, and you move that virtual machine across. A great way to view this is this also allows you to use your recovery side as a way to test your R2 upgrade. Once you've upgraded your Replica side, then you can upgrade your primary side. So here I'm showing you with cross-version live migration, but this is also true of in-place upgrade. Always upgrade the Replica side first. So this is pretty much my final slide. Something that we like to highlight is we think Hyper-V Replica is great. We've done a lot of work on it, but it's also not for every scenario. You know, if you come to me and you say, hey, Ben, I've got 2 data centers and I want to replicate 1,000 virtual machines between them, I'm going to say, great, go out and buy a SAN and use hardware replication. So this is just a handy table that steps through how we compare to different things, when you should use hardware, when you should use software, you know, how this compares to clustering, how this compares to backup. So a key thing to understand is we think all of these technologies have their place to play. So please don't be thinking that Replica replaces one of them. It augments. So with that, we're pretty much out of time. I'd like to thank you all for your attention. And if you have questions, please feel free to follow up with me afterwards. And I hope you enjoy the show.